Complex conjugate. So if you're given a complex number, say z equals to a plus bi, and we know that this is imaginary and this is real, which makes this a complex number. Therefore, the conjugate, which we write it down as the z star, we call it conjugate, is a minus bi. The theory is that easy, but then to use that, we will be further elaborated with other information, which is the roots, because the root could be found with the formula. So this is the quadratic formula. We could find a quadratic root because this is plus or minus, which is plus or minus here, which makes us will be able to find out a equation or expression, polynomial, when you are given a certain complex number. For example, given one minus 2i is a root, find the quadratic polynomial. A quadratic equation. So to do that, there are some people use the sum of root and the product of root, which is x squared minus sum of root x plus product of root equals to 0. However, I will use a more basic way to reverse finding the I will reverse by reversing the situation. For example, 1 minus 2i is one of the root. Therefore, 1 plus 2i will be the other root because the plus and minus sign there. So if that is the case, then our equation will be x minus 1 minus 2i, the one root, and the other root. So expand that, we have x minus 1 plus 2i and x minus 1 minus 2i. Then I can see a difference of 2 squares, so we have x minus 1 square minus 2i square. And then we have our equation. A squared minus 2ab, so minus 2x plus 1, and then plus, because I squared is negative 1, and then 4, so we have plus 4. Therefore, we'll have our equation x squared minus 2x plus 5. However, we miss out something because this might be an expression there, so we'll leave it with an multiple in case they have put the a to the other side. We leave it like this, and this is how we use the conjugate.